Okay, so let's do number 2 from 4.4, the guided practice. Okay, so here's our square root function, so we have to determine all the little things that we need to determine. But first, okay, I mean the properties, not all the little things, but whatever, the properties. But first, what do you see here? We have this 3 here. The coefficient of x has to be 1, guys. So what do we have to do? We have to factor that 3 out. When we do that, we get x plus 3 minus 2. Now it looks like the form that it should be in. Okay? So let's go ahead and do the vertex first. What's the vertex? The vertex is -3, -2. So what's the translation based on the vertex? The parent function has a vertex at 0, 0. That means we went left 3 and down 2. Okay, now let's go ahead and look at the a value. I'm going to do it in a different color. Let's look at the a value. The a value is -1/2. So a is less than 0, so that means it reflected off of the x-axis. Okay, also the absolute value of a equals 1/2. So the absolute value of a is less than 1, which means it is a vertical compression. Okay? If you get confused still with that, there's a video for you to watch. Okay? I made it earlier, I don't know, a couple weeks ago, with a fisherman, and it's vertical or horizontal rod. I would highly recommend it. It should win the next Academy Awards. Just kidding. Okay, let's look at the b value. The b value is 3. It's not less than 0, so it does not reflect off the y-axis, but the absolute value of b equals 3, and the absolute value of b is greater than 1, so it is a horizontal compression. Remember, compression means narrow, and stretch means widen. Okay? Now, we've described this square root function. Okay? The vertex changed to -3, -2. It's going to reflect off the x-axis. There is going to be a vertical compression. It's going to get closer to that x-axis. Also, it's going to be a horizontal compression. It's going to get closer to the y-axis. Now, let's go ahead and state the domain and the range. Now, how do we know what the domain and the range is going to be? Well, the way that I do this, different color. Okay, the way that I do this is that first I look at the parent function. Here it was 0, 0. Now from there, we had -3, -2. So it changed the vertex. I'm just going to draw a rough sketch. Okay, while they're breaking things down and downstairs. I don't know, my mom I don't know what she's doing. Okay, and then look here. There was a reflection off of the x-axis. The vertical compressions, the horizontal compressions, that is not going to make a difference in the domain and the range. Okay, guys? Because the starting point is the vertex, and whether it goes right or it goes left or up or down, that doesn't change. Whether you go just a little bit left or a little bit right or a lot up or a lot, no, it doesn't matter. You're still going to go up the same way, and you're still going to go down the same way. Or you're still going to go right the same way. You're still going to go left the same way. You may go in a little bit more increments or a little bit less increments, but it doesn't matter. That's what the vertical compression and the horizontal compression does. It changes the increments that it goes in, but the direction doesn't change. Now, did it reflect off the y-axis? No, but it reflected off the x-axis, so it's going to look like that. The vertex is the same, but it's going to look like that now. So what's the domain? Did the domain change? No, it's still going to go right. It's still going to go right. So let's see, reflected off the x-axis. So x is going to be greater than or equal to -3, or you can write starts at -3 and goes to positive infinity. Now, the range changed. The range changed, so let's look at the range. That is y is now less than or equal to -3. So it starts at negative infinity, because we write the bottom first in the interval notation, and then it goes to -2. I hope this helps. Please tell me it helps. Bye, guys.